I do want to mention that I am going to cover some of these slides pretty quickly, and at the end I've got a bunch of potential resources for you. So I also have my contact information at the end. So if you want a copy of slides, just reach out to me. I'm happy to send them to you. So this is probably the least technical presentation you might have at this conference. And it's probably kind of an unusual title. I always wanted to try to use the word musings in the title of a talk, so I finally arrived. So why musings on software developer maturity and growth? So I've got three reasons for this. One, as Ken mentioned, I've been in this industry for over 30 years now. When you've been doing something for a long time, you start to realize how valuable your experience is and how much you lean on that, especially as you start working with younger people in your company or in your community. It also causes you to do a little more reflection about what you've learned over those years, and some patterns you might see and how the industry's changed. So that's one. The second one is, for those that don't know me, most people coming into the industry today are probably have some sort of a classical education. They went to school to work in this industry. I am not one of those people. My undergraduate education is in electrical engineering, and this is the actual textbook, which I dug out of a box this weekend, of the only programming class I took in college. So that's it. So I am very much a kind of somebody who's had to kind of learn this on their own. So I used to think that this was a liability, and I think for a while it was, because I was missing a lot of knowledge and information that would have been useful. But over time I started to realize that this might have been something that was an advantage for me personally. A couple reasons for this. So I have been very active trying to understand the gaps in my knowledge and skills, and trying to figure out what are the resources I can use to try to kind of fill those gaps. I've also had the advantage to be able to work in organizations where I've been able to apply what I learned. I know that's not always something that's available to a lot of people. And then throughout this whole process and combining this learning with my experience in engineering, I started to really understand kind of the breadth and depth of software development and how it can be and probably should be treated as a software engineering discipline. The third reason is, as Ken mentioned, helped start a company about 11 years ago called Delpenic Labs. And when we started that company, we knew that we wanted to build a culture that had a strong desire to practice software development as an engineering discipline. This became a great kind of laboratory, if you will, for us to really put these things into practice and really try to grow and evolve this and really see what this looks like. And so as a result, the people that work in that organization, their path to growth has really been defined by how well they grasp what we're trying to do. And so that also kind of caused a little bit of this reflection on maturity and growth. So, musings, what do I mean by that? There's a couple things I'm going to talk about today. One is I'm going to try to kind of relay or characterize or illustrate what I've observed as the stages of developer maturation. Again, this is probably primarily from my own experience. And then I'm going to combine that with some reflection or some ideas about what a path to growing through those stages might look like and where maybe people should focus. Now, when I started thinking about this, and probably the first thing I started thinking about when I was reflecting on how people grow and mature in this industry, I immediately leapt to those people that I worked with over the last 30 years that I thought they were the pinnacle of their profession. And what was the things that really stood out about those people? Well, one thing that stands out to me is they profoundly learn from their experience. They don't just kind of realize that they're learning things as they go, but they actually are active about trying to leverage that. We often talk about how much pain we kind of suffer in software. They don't just endure the pain, they look for ways to overcome that, to prevent that from happening again. They also recognize that, in many ways we tend to, especially as we're younger, tend to gravitate to kind of clever or esoteric solutions to problems. We're trying to use esoteric technologies. But as people mature, they realize, hey, you know what, if I pick a simpler solution now, it's probably going to pay off in the long run. As a result of their experience, they also are pretty good at what we call at Delpenic Labs the ability to see around corners, the ability to anticipate things not yet seen, or to see where things might be going, and to build that into their decision-making and trade-offs that they're doing. Then they recognize that and this is, for me, has been life in general. When you're younger, you tend to think that things are pretty black and white. Yes, no, right, wrong. As you get older, I think you start to realize the world is really more shades of gray. And that's very true in every field of engineering, which means we're constantly making trade-offs between two desirable outcomes. And that becomes the norm of what we're doing. They also invest in themselves. So they very much recognize the limits of their knowledge, and they're very active about trying to overcome those limits. And as a result of that, their skills and knowledge tends to transcend the technologies or the frameworks or the programming languages they're using, which makes them way more valuable. They understand the importance of repeatable processes that produce successful results more often than not, right? So they're more focused really on how we're doing things, and necessarily the what or the what with. They also, they can be, it's important to be kind of, as you'll see when I start defining software engineering, it's important to be disciplined and structured. So you want to have strong beliefs and strong ideas about how to do things, but you don't want to get so dogmatic that you're not open to new ideas and how things should be done. And then they understand that the importance of process and discipline, but won't let that ineffective process get in the way. So we don't want to just adopt things because I read it in a book and that must be the way to do it, right? We don't want to just blindly, we don't want a cargo culture, if you will. We want to make sure we're discerning and trying out what new processes and techniques we're using, and discard those things that really aren't working or providing value. We want to be as lean as possible. They are obsessed with quality. And the first thing I think about when I think about the best developers I've ever worked with, I don't think about how skilled they were as programmers. I think about how good they were as testers. The way they planned testing, the rigor to which they designed and tested the software they did and what others done. I think that obsession with quality, if you really want to, I tell young people all the time, if you really want to differentiate yourself from the rest of your peers, get really good at testing. Be the person that everybody looks to in terms of the person who creates and tests their code better than everybody else. They also understand that it's not just about the programming, it's about the design. And that we maintain these systems over time. We don't just build version 1, throw it out there, move on to the next project. Any software that's really worth anything is going to evolve over time. And the only way that's going to be effective is if we really invest in good design. And then when in the heat of the moment, when a decision needs to be made and we need to do something, this may be particularly true when we're working on hot fixes, they tend to step back and think a little bit more strategic about that. And go back to that whole idea, we need to trade things off. It's not just about being responsive and getting a solution for this immediate customer. We don't want to do these little things that tend to erode our systems over time. And then they understand that software development is a team sport. And like any team, you don't want to just have players, you have to have strong leadership. You have to have somebody there who's keeping us all together, making sure that we're all on the same playbook and running the same play, and that we don't have any weaknesses within our teams. So that's where I started. Hey, what are those great developers that I work with? What do they look like? So if our aspiration is to try to kind of be one of them one day, what does that path look like for us? What should we be doing, or how should we be approaching this? Well, to start with, I felt like we need a bit of a framework for this. How am I actually evaluating these developers that I'm talking about? How do I evaluate what they should be learning? Well, I think it's important for us to, let's start thinking about this in terms of software engineering and not just programming for software development. And I'm sure you've heard that before, and we tend to throw this word around a lot, software engineering. But in order for us to really dig into this, we need to understand what does software engineering really mean. So let's make sure we have a shared definition of what that is. And then let's also talk a little bit about what's the end game like. When we're actually practicing software as a software engineering discipline, what does it look like? What should we expect? And then finally, we need some sort of a knowledge and skills map for us to kind of be at least a little bit rigorous about how we're evaluating people. So I think this is the best definition for software engineering. It comes from IEEE, which is a name we should trust, and has invested a lot of energy and resources into trying to really define what software engineering is. So I'll just read this to you. Software engineering is the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. In other words, the application of engineering to software. And one thing I like about this is if you look at the definition of other engineering disciplines, it looks very similar. It's very short to the point, and it contains this systematic, right? So that means we have a method, we have a system for how we develop software. Discipline means we're following that. We're consistent in the way we do things. We're not just ad hoc or randomly choosing approaches. And then quantifiable, which means, hey, we have some sort of way of measuring on what we're doing, where we have a feedback loop that can kind of improve things. So the next thing is, okay, so what does an end game look like when we're practicing software engineering or software development as an engineering discipline? Well, unfortunately today, this isn't always the case, but by and large, over the last 20 years or 30 years of my experience, the success of a lot of the projects that I've seen and observed has really been based upon what I'll call a virtuoso performance by a handful of developers. Or those developers that have some sort of tacit knowledge and skill that were able to bring it over the goal line despite the fact that, the rest of the team might have been, not contributing or holding them back. So, or some of us, have probably been involved in death marches where we're working 60, 70, 80 hours a week just to try to get things going. So that's really kind of, for those complex problems that we've been working on in the past, by and large, that's been my experience and my observation. One of the challenges with this, we could continue on down this path, but one of the challenges, the types of problems we're trying to solve today really are orders of magnitude more complex than the things I was doing in the late 90s. We built an e-commerce platform in the late 90s, early 2000s, which was really hard, and we had some success with that. I look at that now, and it almost looks naive compared to what e-commerce looks like today. And one of the companies we built at Nebraska.Global is it builds computer vision applications for athletics, performance, and healthcare. 10 years ago, if you told me we were going to be building computer vision applications with a small group of people in Lincoln, Nebraska, I would have thought that's way out of our league. We wouldn't be able to do that. So software is everywhere. I don't have to tell you that. But the problems we're trying to solve with software will continue to grow. So really, what the future could look like, and probably should look like, is to have this body of knowledge, this shared understanding of what is software engineering and what does it mean, and that we all understand this. And this becomes our guide for how we approach things. Think about if I hire a bunch of civil engineering firms to design a bridge over the Platte River, do you think they're all going to be radically different in their approaches, and they're going to radically apply a random or completely different set of rules and knowledge to that? No. The bridges are going to look different. They might use some techniques that worked for them in the past, but they're all working from the same and guided from the same principles. So with that, the solutions to common problems that we're dealing with should be shared and should be things that we can reuse these things and over time. And this is something I think we're actually seeing today. Because 10 years ago, the cloud was all about hosting applications. But over the last 10 years, you're starting to see services in the cloud that are available for us to, whether it's authentication services or machine learning services and things like that. Those are hard problems to solve. They're common problems that we can then use to build our applications. So I actually think we're seeing some of this more and more today. But when we combine these first two things then, we should be able to take, just by average I don't mean mediocre, I mean just your average software developers should be able to tackle these problems using these first two bullets with a consistency, routinely and predictably, and have success. Much like if I go to Olson and say I want you to design an overpass, they're going to do it. They're going to do it 99.9 times out of 100 successfully. That's what you want. You want that predictable outcome. And then, so for some of these novel things, some of these, like building cloud services, those are exceptionally difficult challenges. And maybe that's where our virtuoso performances really should be focused on. Those things that, for me, I'm never going to be involved in those types of problems. I'm going to be the person this is where I want to live. I want to be solving complex problems, but I want to be able to do it predictably. And really, with very few exceptions over my career, none of the projects we worked on did I ever doubt there was a solution to a problem. I think for the most part, there is a solution. That's fairly deterministic. It's those rare challenges that maybe require that virtuoso performance and that innovation. All right, so the third thing we need is this knowledge or skills map. And I want to go back to IEEE again. This is something maybe some of you have heard of that I suspect many of you have never seen before. And that is the guide to the software engineering body of knowledge, which is now in its third version. This is something that has been developed by IEEE over the years. And it is something that's common for a lot of other engineering disciplines. So you can go out there and find the systems engineering body of knowledge and the electrical engineering body of knowledge. So this notion of a body of knowledge is very common, especially within academia and in much of industry as well. So there is a collection of what we know about software engineering. And this book is your guide to that. So the SweetBox has some specific objectives of what they're trying to do. They want to make sure that we have throughout the world, we have a common view of what software engineering is. And then they want to characterize or describe the contents of that body of knowledge. This does not contain the body of knowledge, it's the guide to the body of knowledge. All right? So that's what they're trying to do, is they're trying to provide you access to those authoritative resources that really contain the body of knowledge of software engineering. And then finally, they want us to use this body of knowledge to create curriculum, which University of Nebraska now has a software engineering degree. It's one of the few software engineering degrees in the country, believe it or not. Most people coming into industry are still getting a computer science degree, which is kind of like getting a physics degree and then want to be an engineer. All right, so the SweetBox actually contains what they call 15 knowledge areas. So they try to characterize all of the different aspects of software engineering into these 15 buckets. And I'll go through these pretty quickly. There's software requirements, there's software design, there's software construction, there's testing, there's maintenance. So kind of the things we kind of are used to doing on a daily basis probably. But then they cover software configuration management, software engineering management, which is kind of project management, software engineering process. So this is kind of our software development lifecycle and things like that. They have software engineering models and methods. So how do we actually, these structured models that we use to design systems and things like that. Software quality, which is not just how we do quality, but how we measure what does quality really mean. And then software engineering professional practice. What does it mean to be a professional as a software engineer? And then software engineering economics, which probably is a shocker to everybody. It's something that we have their business, but we're part of a business, right? The decisions we make have an economic impact on our business. So this is an important aspect as well. And then there are three foundational things, three kind of like table stakes to get into the field that aren't really directly related to software engineering, but are essential bodies of knowledge that we should be aware of. So in engineering, your first 2 years, you're taking physics and math and chemistry. You're not taking any engineering classes. You're taking classes in these foundational areas. And so one of these is computer science. It has a whole body of knowledge there. The other one is mathematical foundations, specifically things like logic and reasoning and discrete math. And then engineering foundations, just some of those common patterns and principles there. All right, so I have these 15 knowledge areas, but that doesn't really help me. I kind of want to group these together to make sense of this. And so what I've done is I've come up with 5 separate areas. I have foundations, I have management, I have execution, structure, and then professionalism. And so what I did is I kind of laid out these knowledge areas within these various areas. And again, what I'm trying to do is build a map that I can use to evaluate the maturity and growth of developers. So I have my execution there, I have my management ones, and across the top then I have the professionalism and ethics. So I'm going to use this to kind of demonstrate this growth and maturation. And since we're really just talking about developers, I'm going to not really focus much on the management side, right? It's part of the body of knowledge, but it's really these other things that I'm really focused on. All right, so I got that. So now it's like, okay, well, how am I actually going to do this? How am I actually going to kind of define these growth phases and their focus? I'm not going to do it by height. We'll leave that to Caddyshack. What I did is I came up with some personas, and these personas really reflect kind of the things, personas within our own organization. So I totally acknowledge this is based upon my experience, and your mileage may vary. It may not resonate with you, but it's kind of what I know. And I'm really just trying to illustrate a process, if you will, and a potential model for you to think about. And I recognize that maturation in any skills and knowledge isn't set up of a bunch of transitions from one state to another. It's a continuum, right? So it's a little bit artificial, but I think that it might help, again, it might help make my point, kind of give you some things to think about. And so I have 5 personas that I'm going to talk about and describe here. And in each one, I'm going to talk about kind of what their skill level is, what their blind spots are, which I think is very important when we talk about growth. Like, what are they not good at? Some of those things that might really differentiate those people that I would consider to be kind of high performers within that particular level. And then areas that I feel like over the years we've tried to really focus on as these developers are growing. So these would be target areas of focus. So the first 2 are what I consider the entry-level developers. And they come in 2 brands. One is really the entry-level coder. And so these are people that either are self-taught or might have gone to a code school. So they don't have they don't have that strong formal background in education. But they do have some experience. They can probably build some websites with some light back end. They probably are familiar with some development environments. And they probably have been exposed to some agile methods, given that that's pretty pervasive now. So they do have some skills. They have some pretty good blind spots, though, as well. And one common one that we talk about a lot is this notion of errors in judgment. Okay, it is something. I'll talk to students coming out of college and they'll work on a problem and you think that they have a lot of knowledge, but oftentimes they don't see around corners, if you will, right? So they make errors in judgment. Nobody is maliciously making mistakes when they're coding. It's these things that really cause us problems over time. People just making mistakes. They also don't have much design and testing experience. And probably the biggest thing is that gap in that foundational knowledge, computer science, mathematics, engineering, they probably don't have that. So the things that really differentiate these people, they kind of realize, hey, I'm a self-starter. I'm doing this myself. I'm hacking my way into this career field. And so they're pretty motivated, right, to really grow and understand and learn. And the ones that are the best at that are the ones that aren't afraid to ask for help. And this is a common one for many people coming into the industry, especially when they're coming right out of school or something like this. They feel like they can't ask questions. Like it makes me look weak, or like I don't know what I'm doing. Well, here's the news for you. None of us really know everything, right? Nobody has the tiger by the tail. We all need to ask questions, whether it's Stack Overflow or the person next to me. So where I think these people need to focus is, let's not just jump right into, hey, I'm going to be a great coder. Let's take a step back and make sure that we're really understanding this body of knowledge from computer science and to some extent the mathematics. I think it's absolutely critical that you get that foundation. Maybe it doesn't have to all happen at once, but that should be part of what you're trying to do if this is you. And then the next thing would be, I want to go into software design and testing, because those are the things that people tend to be the weakest in. They tend to understand the syntax and the structure of programming. They tend to not really understand what it means to do design and how to test. So this is what they look like. It's pretty sad. This is what this represents is they have some experience in software requirements and some experience in software construction. Everything else, kind of a blank slate at this point, right? So this, really want to focus down here in foundations, and then really want to start building some knowledge and expertise in these areas here. So the next one is the counterpart to this. This is the entry-level computer science grad, the students coming right out of college, right? So they typically have some sort of a bachelor's degree or maybe an associate's degree. They probably have a pretty good CS and math foundation. That's really the focus of a CS undergraduate education, is in that area. They probably have some what I consider to be generic programming experience, all right? So they probably worked on some academic assignments. Maybe a few of them have had some internships, maybe hopefully most of them. Blind spots. They don't have a lot of experience in developing actual applications unless they have actually worked in an internship. They also are prone to errors in judgment, right? And then they tend to have gaps in that engineering foundation at the bottom. And again, little to no skills in design and testing. You can't find a class at UNL for computer science probably that says software design, 3 credit hours. We're just going to be talking about software design or architecture. The thing that differentiates these, the ones that have a lot of internship experience. So if there's any students in the crowd here, if you're not getting internships, try to find those. They should be available to you. But those ones, they tend to come in and they have a better perspective on what it really means to develop software. And they also aren't afraid to ask for help. So here, no surprise, that software design and testing is really where we really try to steer these people to focus in. So there's what's a little bit different than the coder, they have a little bit of experience. I'm not going to say they don't get any introduction to this in their education, but it's pretty lightweight and not sufficient. But they're really pretty strong here. All right? This is where I want them to focus, design and testing. All right, the third one, the experienced developer. You got some miles on the tires now. You've had some experience. They typically have good programming skills across a lot of different technologies. So they know how to use, they know how to program, they're good at that. They're starting to maybe emerge some analytical and critical thinking skills at this point as well. And they're starting to kind of understand kind of what it means maybe to be a professional in this organization and the ethics around that. And if they're in the right organization, they're probably starting to see and understand the importance of some of these management processes and models and methods. And they've probably also been asked to provide support, so they've got some experience in maintenance. Problem is, they can follow the patterns maybe that you have in the organization, but they probably can't explain the why. They're just like, just do it, because that's what we need you to do. They're probably really not understanding the underlying reasonings behind it, but that's okay, they're learning, right? The errors in judgment is still a problem with this group, so that's not going to go away anytime soon. And then understanding of what makes a design good or bad. This is a very difficult thing, I think, for a lot of people to understand. Because again, we live in a world of gray, right? The top performers here, I like to think, I have this term like humbly confident. You don't want people that just don't have confidence to kind of go out there and tackle things. But you don't want them to be so confident that they feel like I don't need help from anybody, right? So they have just enough of that imposter syndrome to get feedback and validation on things. And then these people also start to get very organized and deliberate about their learning. They seek out, what should I be learning? What resources should I be using? I really want to grow here. And this is an important one too, the differentiate. They start to really care more about the quality of testing. It's not just about fingers on keyboard and coding. So again, software design and testing, this is so important, and it's such a weakness I feel in a lot of these more junior people that I don't want to forget the fact that they still have to do that. But we can also layer in some, hey, let's start thinking about some of those structural things. How do we actually architect things? What are our methods for doing that? What are the sort of things we do in our software development process that really help create these predictable outcomes? So their map's starting to look quite a bit different. They got a lot of instruction phase. That's what a lot of them are doing. They're coding, right? So they're getting a lot of experience there. And now they have at least some working knowledge of a lot of these different areas, and maybe even over here in the structure area. We're starting to fill this thing out nicely. But again, I want them to really focus here, and then also over here. Fourth one, the emerging leader, what we call the emerging leader. All right, so these people are really starting to get it. They're starting to see what we're trying to do. They're starting to advocate for these things. They're going to say, they're trying to make sure that people aren't cutting corners. We really want to follow this process because we've seen it work, right? So now we're starting to really understand that the need for the application of a systematic, disciplined, quantifiable approach to software, because they probably have had some bad experiences and realized, hey, we want to follow the path, we want to be disciplined about this. This one here is interesting. They start to be empathetic with the customer a little bit, maybe even advocating a little more for the customer there. And then they can effectively apply patterns and practices not only in their own work, but they can coach others during code reviews. And now we start to see the errors in judgment start to decrease, right? They're making good, solid judgments in that world of gray that they live in. Testing expertise and design expertise still emerging. This is a skill that you just don't read a book and you're going to be good at it. You have to do it, you have to practice, you have to get feedback over time. And so, but they're getting there. This one here, though, is interesting. So what I've seen is people get to this level here, they have some confidence, they have some credibility, problems come in, and they're just like, all right, we're just going to solve this problem, I can solve this problem. And they start to get, sometimes, maybe a little too focused on being responsive and losing sight of the fact that let's take a step back and be a little more strategic about our thinking. And let's not just push a hotfix out there only to find out that it broke something for some other customer, right? So they need to be that person who's kind of, whoa, let's hold back on this a little bit. Top performers here, they start to be able to coach others. They care deeply about software design, even if they're not able to do it on their own consistently. They're getting better and effective at testing. And now they're starting to seek out mentors to kind of help them on their journey. So now we can focus way more on just the structure side. They got everything else in the middle kind of nailed down. This is what their map might look like. And this is where we want them to focus. And the last one is the software engineer. All right, so now these people, they can consistently get successful outcomes in their project, regardless of the complexity. They recognize when things are ill-defined or where we don't have a necessary process for things, we're leaving things to chance at that point, and that could cause problems down the road. They're always looking for ways to not just follow the process, but improve it. What can we do what other techniques might we use to solve that problem or plug that gap in our process? And then they start to think about it. We're engineering software, we're not just developing software. In terms of blind spots, it tends to be outside of their area. Now you get to this point, you want to start thinking about how other engineering disciplines solve problems. You want to start learning about what systems engineering is and how that can be reflected. You start to be responsible for getting us to a point where we're practicing software as an engineering discipline. The top performers here, they're the ones that can help guide and define the process, the way we're doing things. And down here, their ability to teach as well as do. Those that tend to be the most valuable people there. Suggested areas of focus, completely outside the software engineering body of knowledge. Start looking at other things going on. Start understanding what engineering really means. Like I said, systems engineering. So now we've got at least a working knowledge in a broad area of this map. All right, so what should I take from this? How do I use this? Well, one, I think it's valuable, if you're not doing it now, do a self-assessment. Maybe use this as a starting point, or maybe modify this, and kind of evaluate where you think you stand on this. And be honest about it. If I'm weak in some area, that's okay, but it just highlights an area where you might want to focus. And then be deliberate about kind of attacking those areas and tracking your journey. Create a path. Like I said, that some of the best developers I've ever worked with, they were deliberate about this. They had a path. They're like, I'm going to focus on this, I'm going to focus on this. I mean, I've got libraries of books that I just continue to try to accumulate and read and reference and try to understand this. It's a journey, but not a destination, right? And if you look at, this is mine. This is what I try to take an honest look at myself. This is kind of where I feel I'm at. It might surprise you that my software construction is maybe a little light here. I often tell people I'm the worst programmer at Panic Labs. If you're relying on me to get the thing done, I feel like I'm relearning some of the language constructs every time I get in there. But there are other areas where I feel like, I've got some strengths down here. My background in engineering. I was a systems engineer for my first 7 years. And so this is kind of where I'm at. I still am trying to really fill that gap here after probably 20 years of focus. Really trying, I still feel a weakness here. And I rely on people like, from our organization, Chad Michael and Andy Unterseer, people like that who have a good education background in this to really help me along. So if you aspire to continue to mature and grow, you should recognize that traditional education systems are not going to get you there. They're a starting point. They're going to get you out there. And maybe one of the best advice I got in college was a professor who was talking to another student who was complaining that they would never memorize how you solve this problem for this power system or whatever. And the professor said, I'm not trying to teach you to memorize this. I want you to learn where to go to find the answers. I want you to know that these solutions to these problems exist here. It's up to you to kind of seek them out when you need that information. Likewise, the experience in your current role is not likely to get there. So if you're just relying on on-the-job experience, it's probably not going to do it. It'll stunt your growth. Not to say you can't ever get there, but it will slow you down. So being the best programmer also does not make you an engineer. Sometimes I feel like we really focus too much on whether I understand this framework or can use that framework to the neglect of all those other areas of the software engineering body of knowledge. And you notice when I talked about the best developers I've ever worked with, not once did I mention they were highly skilled programmers. Because I think most people that spend time in this industry become highly skilled programmers, right? And then finally, maybe your progress will be dictated by your efforts and to be brutally honest, where you choose to work. So some organizations are really devoted to applying this and trying to grow and change the way we're doing things. I'm working with a company in Omaha, a large company in Omaha. They are devoting tons of resources to try to level up their development staff and to try to have a broader understanding of software engineering. That's incredible. I don't see that everywhere. So organizations are a little bit different. I'm not telling you to leave your job, but I think you should recognize that could be a strength, and it might also be a weakness. So I highly recommend also that you try to identify mentors, and I put this in quotes, so define mentors however you want, but some resources that can help provide you guidance, right, in coaching. That might point you in the right direction, or maybe help you evaluate yourself and where you're at. And then leverage the abundance of resources that are out there to help you with your gaps. And I'm going to go over some of these here to kind of end the talk. So, if you're looking for an index to software engineering, like that point where I want to learn about this, where do I go? I mean, that's really what the guide to software engineering body of knowledge is. But I would also throw in this book here, because some of you probably heard me say this before. If I had to have one book on my shelf, and I can only have one book on my shelf, this is the book I would get. Because Steve McConnell's attempt was to try to bring together the body of knowledge of software development into a single book. And this is an incredible reference. I've used it, I have not read it cover to cover, but I've used it as a reference for a variety of different topics, and you're going to see it often in this list. The other one is under software design. This is an eclectic group of books. Some of these are very pointed, like patterns books, like design patterns. Some of them are more architectural, like building evolution architectures and writing software by Yuval Louis. Some are more code complete again, not heavy on architecture, but does talk a lot about detailed design. Then you got Robert Martin's book on agile patterns, practices, and principles. Then you have this book down here by a faculty member out of Stanford, A Philosophy of Software Design. It's about a 100-page book, but it was just delightful to read about his experience there and learning from that. And then this book by Fred Brooks, who wrote The Mythical Man Month. This is just a series of essays on the nature of design, which I just thought was a fabulous book. Software testing. There are a lot of books on software testing. This is where I would start. He devotes numerous chapters on kind of defect detection and testing, which I think is a great, it just boils things down for you in a way to get you started. And you can get going with that. When it comes to software engineering models and methods, I'll be honest, I don't have a lot of great references here. I have Yuval's book, Writing Software. And then I know that Eric Evans with his domain-driven design. Those are the only two things that I'm familiar with. There may be a few others that are prescriptive enough that can kind of get you to not only just understand the concept, but put it in practice. An average engineer should be able to take this and put it in practice. Too many books kind of leave things at a high level and don't really give you a tool set. Computer science fundamentals. Again, I throw this up here because this is super important. I think a lot of us, especially people like me, kind of come into this from other backgrounds, are weak here. And there's a number of these. Once again, Code Complete. But this book here by Charles Petzold, who used to be a big author in the Win32 API, this was not only is a great book on kind of how computers work and the hardware side, but it was just super fun to read. I really highly recommend that book. And then this guy, Rob Connery, who's very much like me, self-taught, he actually went about trying to write a book specifically for people like me. And he called it The Imposter's Handbook, which I thought was a great title. But he's trying to learn those computer science fundamentals and express them in a book that is very approachable for people like me who are kind of self-taught. All right, and then finally, there's just some other interesting, useful sources that I think were great books. This is a book that, if you really want to understand kind of how we got to where we're at in software development, Adam Barr does a great job. I think this is a great read, especially for people of my generation who might have been around in the 80s when the PC revolution came around. Making Software is actually a collection of rigorous research studies that are more kind of translational, so they apply to what we do today. So there's studies of how organizations like us, like we belong to, what success they've had, and kind of what does the data tell us in terms of what things work and what things don't work. This is the book that Ken referred to. This is Chad and I spent some of our pandemic kind of putting some of our thoughts in place in this book that Ken mentioned. And then this one over here by Capers-Jones really has a ton of data, like quantifiable data about how, again, what things work in software and so forth. All right, I think I almost nailed it perfectly at 40 minutes. So thanks. I appreciate the opportunity, Ken, to come and talk to everybody. I hope you took something away from this a little bit. If you want the slides again, here's how you can reach me. This is one of my favorite quotes by Gerald Weinberg, who's pretty famous in the field of computer science. Actually grew up in Nebraska, so just outside of Lincoln. So thank you.